the equations. This is what you would do. So let's say I give you y is equal to 7x squared plus 8x plus 5, okay? And you are supposed to test to see what it's symmetric to. So and things can be symmetric to the line y equals 5. It could be symmetric to the point 2, 4. But we're only going to test x-axis, y-axis, and origin, okay? So is this symmetric to x-axis, y-axis, or origin, okay? So that's what we're going to try. So the first thing you do is plug in AB, because that's what we're always going to compare it to. You could, I suppose, find a number. I'll give you the more general way to do it with letters, but if that doesn't make sense to you, you can actually do it with ordered pairs, with the numbers. So if you do AB, then that means B is equal to 7A squared plus 8A plus 5. This is what we're always going to compare it back to and see if it works. So if we want to test the x-axis, then we want to test AB and A negative B. AB and A negative B. So I'm going to plug in A negative B. So that means negative B would equal 7A squared plus 8A plus 5. If I divided here by -1 to get my B's the same, because what you're trying to do is see if you can get them to be equivalent. If I can divide by negative B, that would give me 7A squared minus 8A minus 5. Both of those are different than my original. There's no way to rearrange this so that they look the same. So this is a no. It is not symmetric to the x-axis. Okay. So let's try y-axis. That would be a negative A, positive B. We already are checking AB. So we'll plug in negative AB and see what we get. So that would be B is equal to 7 times negative A squared plus 8 times negative A plus 5. Well, this works out okay because negative A squared is 7A squared. But this is minus 8A plus 5. This is different than my original. So this is also a no. It's not symmetric to the y-axis. Usually by the time you do x and y, you can tell what the origin is going to come out to be. But let's plug it in and see. Negative B is equal to 7 times negative A squared plus 8 times negative A plus 5. Negative B is 7A squared minus 8A plus 5. Even if I divide by negative B, I'm still not going to be equivalent. That'd be negative 7A squared plus 8A minus 5. So this one is not symmetric to anything, and that happens sometimes. Don't think that it has to be symmetric to one of them. Most equations are not symmetric to any of those. But if my equation, well, let's do a whole new piece of paper. If my equation was y equals 11x squared minus 3, okay? Start with AB. So that's going to give me B is equal to 11A squared minus 3. We're going to check A negative B. So that would be negative B is equal to 11A squared minus 3. That's definitely not true, so that's a no. And that's for the x-axis. If I check negative AB, I get B is equal to 11 times negative A squared minus 3. But this one simplifies. Negative A squared is the same as A squared. So this is 11A squared minus 3. So that is, like, that's exactly the same. So this is a yes, it is symmetric to the y-axis. Now I can tell if I plug in a negative A and a negative B, it's not going to work. But go ahead and do it. you'll get to where you can do shortcuts. Because it's going to change the sign of the b and the a, but the 3 is still going to say minus 3. So negative b is equal to 11a squared minus 3, so that is not the same.
So the a's and the b's, those would be numbers for our homework, right?
No, you'll use actual a and b.
Okay.
Now, if that doesn't make sense to you, then you can pick an ordered pair. So let's say, but you have to find an ordered pair that actually works. So let's say the a's and b's don't make sense to you. And so you want to find an actual number. So let's say you plug in 2 for x. You have to find the y that actually works for it. So if you plug in 2, you get 4. So that would be 11 times 4 minus 3. 44 minus 3 is equal to 41. So you have the ordered pair 241. So you know on this graph 241 is there. So you need to check and see if negative 241 is there. You need to see if negative 2 negative 41 is there, and if 2 negative 41 is there. So this checks, this is your original point, this checks your y, that checks your origin, that checks your x.
So it's just more work.
It's not any, no, it's not more work than doing the a's and b's. You would do this instead of the a's and b's. Some students prefer this, some students prefer the letters.
But if you have to check all of them.
But you're just going to glance at it because it's the signs. Like, you know 2 and 41. Okay, so let me show you. So if you plugged in 2 and negative 41, you're saying that negative 41 would equal 11 times 2 squared minus 3. You can just glance at that. Like, you don't have to do the arithmetic. Like, you can see that's a positive number. Like, if you know that 11 times 4 minus 3 gave you 41, it's not going to give you negative 41. So that's a no. Now, if you try negative 2, let me write this over here. This is 241. So if you try negative 2 positive 41, that'd be 41 is equal to 11 times negative 2 squared minus 3. If you look at that like, oh, that's going to work, that's a yes. Do you see what I mean?
Okay.
You don't actually have to do the arithmetic and solve every time.
Okay.
Some students can really see this a lot better than this. Okay? So then if you plugged in both, you'd be like, oh, well, I can tell negative 41 is not going to be the same as that. If I change both the signs, it's not going to work. But if you have an equation like y equals negative 8, no, wait, I don't want that. I want negative 8xy is equal to 40, okay? If you check AB, that's negative 8ab is equal to 40. If you do negative AB, that's negative 8 times negative a times b is equal to 40. That's 8ab is equal to 40. That's different, so that's a no. If you plug in a positive a and a negative b, that's a negative 8 and an a and a negative b. That's also 8ab. That's different. But if you plug in negative a and negative b, you get negative 8, negative a, negative b. Two of the negatives reduce, and you're left with a negative 8ab, which is equal to 40. So that would work. That's a yes. So this one will be symmetric to the origin, but not to the x or the y. This one might be something that works better with numbers. If you take a negative 8 times, what do I want? Times 1 times negative 5. That would equal 40, wouldn't it? So that means the ordered pair 1, negative 5 works. So if you try negative 1, 5, try 1, wait, let's just change that. If I change the x, if I change the y, or if I change them both. If I do this, negative 8 times the negative 1 times the negative 5 is not 40, because I should get a negative number. If I plug in two positives, negative 8 times 1 times 5, that is not 40. Negative number is not equal to 40, so that's a no. But if I change them both, negative 8 times a negative 1 times a positive 5 does equal positive 40, so that's a yes. So this one is symmetric to the origin, but not the x and y. This is doing it with numbers. This is doing it with letters.
So the letters one, you're just making sure the equation is the same, and the other one, you're making sure it equals.
Mm-hmm. Yeah, right, right.